All right, welcome back. You made it, or you're here. Okay. We graphed. Your hand probably hurts from graphing too much, but it's good. Practice doesn't make perfect, but perfect practice makes perfect. So hopefully you didn't, you know, I don't know, go too fast or maybe trim the edges a little bit. But guess what? You only need your notebook to write things down. For instance, you might want to write down directions on what I'm about to do. So turn to page 7. And again, you're going to read the example. It's great. I'm sure it's wonderful. But I'm going to go down to monitoring progress. We're going to do 8, 9, and 10 at the bottom because I want to show you something. So this is the 21st century, and you're going to eventually be out of high school. You should be prepared to use technology for whatever your future holds. So if we are in class, I'm filming this during the COVID quarantine of 2020, and yeah, maybe I might reuse it. We're going to be using a graphing calculator because it's a great tool. You are allowed to use them on the SATs, the ACTs, the AP tests. It really does help do some of the math that you don't really need to do. That way we can see the deeper level of what's going on. But I also want to show you how to use Desmos. It's a great website. When you're home, you might as well use it to do most of the problems that you should do on a graphing calculator. There's something to be said for doing some problems not on a graphing calculator. All right, but let me show you how to use Desmos. You might never have used it before. It's actually kind of new to me. I'd never really used it. I would always just use my graphing calculator. Okay, so you can go to desmos.com as you hear my voice, and I switch the screen to desmos.com. Oh, hey, there I am. I do need to figure out, note to self, I need to make sure my face is in the videos even when I have my notebook. So you remember there's a human there. All right, and it should take you to the graphing calculator. If it doesn't, go to the graphing calculator. Okay, directions, number 8 on page 7. Use a graphing calculator to graph the function and its parent function. All right, cool. We're not going to write h of x, but we are going to write y equals. All right, y equals. And then we're going to type it in as carefully as possible. -1/4. Now, look, if I hit x right now, it's going to go in the denominator. So I need to hit the right button to make sure I have x, and then +5. Oh, what type of function is it? Use your words. Is it a constant, linear, absolute value, or quadratic? I had to think about that for a second. Hope you said linear. I'll zoom out 1 for you. All right, we graphed the function. Now we have to graph the parent function. Y equals x. Ooh, a lot of things have happened. All right, now wait a second. It's a linear function. So what's the slope? What's the y-intercept? All right, great. These are not really going to be part of our vocabulary. But we are going to say, and I took a dramatic pause so you could be ready to write it down. We are going to say the description. Let's see. Our function moved up 5, right? I mean, that's the y-intercept. It moved up 5. And except then it reflected around the, now technically the x-axis, but in this case, we're going to say y-axis. And pause. Don't freak out about how I'm just changing up some of the rules right now. It's a line. It's fine. It's a reflection around the y-axis. You actually can say x-axis if you want. And then it is a vertical shrink by 1/4. All right, so let's keep it all together. And the reason why it's a little weird is because lines are actually so simple, no offense to a line, that it's actually kind of hard to see the different kinds of stretches and shrinks and reflections. So let's just keep it simple. We know that there is a translation up 5 units, so it went up 5. There is a reflection, and let's, you want, if you feel more comfortable, reflection about the x-axis, because it's true, and a vertical shrink, because it's a fraction of 1/4 by 1/4, a vertical shrink by 1/4. Okay, from the parent function. All right, you got that? Do you need to pause? Do you need to rewind and hear me say it again? Because I don't need to say it for a 3rd time out loud. All right, and okay, that was that. So now we're going to go back and we're going to do a different one. So let's do number 9. So this is what's written in the book, so I'm going to delete that. And you're practicing with me, right? So you can always pause and try it on your own. Again, I'm not doing this because I need to. I'm doing it because you need me to do it. All right? The more math I do, the better I get. And I'm not getting graded. Okay. The more math you do, though, great story. The more math you do, the better you get. And you learn not to type in the at symbol for squared. All right. So graph the function. There it is in red. And its parent function. There it is in blue. And then describe the transformation. All right. So what do we think happened? You know what? I like reading right to left in this case. So I'll do it both ways, right to left, left to right. It went down 1, right? Don't we agree? It went down 1. Looks like it went to the right by 5, right? Look, went over to the right by 5. And then, see, these are better to look at for vertical stretches or shrinks. Did we take our parabola and did we stretch to get it more narrow? Yeah, we did. So it's a vertical stretch by 3. Okay, so let's start again. We went down 1, right 5, vertical stretch by 3. Or you could say vertical stretch by 3, right 5, down 1. But there you go. There's your transformations. Okay, one other thing. Now, I'm okay with graphing this stuff. Here's something new that I haven't really done. Number 10. You can hit the plus sign and we can insert a table. For our x's, we're going to type in the x's for number 10. 0, we're going to go down, 10, 20, 30, 40. For our y's, we're going to type in the y's that go along with them. Now, you need to double check with your eyeballs. Did you match up the x's and the y's appropriately? And I hope the answer is yes, but you should check. And I checked as I said that very slowly. So here we go. Now, the question says, the directions say, the table shows the amount of fuel in a chainsaw over time. What type of function can be used to model the data? When will the tank be empty? All right, so what type of function? So what do you think this, like if we were to connect these dots, would we have a constant function, linear function, parabola, or absolute value function? A linear function, right? It's going to be a linear function. One way you can know is that for every 10 that the x's go over, the y's go down 3. For every 10 the x's go up, the y's go down 3, and it's constant. It's a constant rate of change. All right. And then when will the tank be empty? Well, what does it look like? If we go over 10 more to 50, what's 3 minus 3? 0. So the tank will be empty after 50 minutes. Okay? And there you go. All right, so I hope you tried the Desmos on your own. Why did I say the Desmos? I'm not that old. I hope you tried Desmos on your own. And I hope that you get more comfortable with it as the year goes on. It is a valuable tool, okay? But until then, you'll have practice and you'll see me in chapter 1, section 2. Oh yeah, and then, the whole class thing. Okay, bye.